Hi, I'm an old guy and I do maths. There isn't a problem to solve today. What we're going to look at is the difference between an arithmetic and a geometric sequence and how to spot that difference. So let's start alphabetically with an arithmetic sequence. Here's one that I've got. 2, 4, 6, 8, 10. Now, there are a couple of ways of spotting that this is arithmetic. There is a common difference. If I subtract 4 from 6, I get 2. If I subtract 2 from 4, I get 2. If I subtract 8 from 10, I get 2. There is always the same difference between these numbers. Now, a consequence of that is that if you were to graph this and you were to call this, say, term 1, term 2, term 3, term 4, and term 5, so I'll number them here, 1, 2, 3, 4, 5, and up the side 2, 4, 6, 8, 10, the actual numbers in the sequence, this is what you would get. Now, this has to be, allowances have to be made rather for my poor drawing, but what you get is you get a straight line. An arithmetic sequence is evidenced by a straight line on a graph. It is also evidenced by the same difference between each two members of that sequence. Not 6 and 2, but 6 and 4, 6 and 8, 8 and 10, 4 and 2. There has to be a common difference between those, and in this case it's 2. So that's the key item, and it is evidenced by it being graphed and producing a straight line. When we take the terms by their numbers and the terms themselves and we plot them. Now, so that's an arithmetic sequence. Now, a geometric sequence is what I've got here. Starting with the same number, in fact, starting with the same two numbers, 2, 4, 8, 16, 32. Something different is going on here. It's a happy coincidence that 2 times 2 is 4 and 2 plus 2 is 4. But if we go a little further, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. We're not adding the same number to produce the next item in this sequence. What we have is we have a common ratio. And that ratio is times 2, times 2, times 2, times 2. How do we discover that? Well, 32 divided by 16 equals 2. 4 divided by 2 equals 2. So if we take a term and divide it by the term in front of it in the sequence, we should, in this case, get our common ratio. It's not always that simple, but this is an attempt to simplify the ideas and explain them. Now, what I'm going to do is I'm going to graph this, and you will see the difference between what we had up here with an arithmetic sequence and what we get down here. Now, I'm going to give these terms the same numbers, 1, 2, 3, 4, 5, and up the side, 2, 4, 8, 16, and 32 are way up here. So this is going to be, again, a poor rendering, but it will give you some idea of what we're looking at. Okay, now I will attempt to draw a line between these points. Now this is far from perfect, but what you can see is that this line is not straight, and that is a common feature of a geometric sequence. The common feature of an arithmetic sequence is that it's linear, and it has a common difference. So let's just look at that again. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Down here, 2 times 2 is 4, times 2 is 8, times 2 is 16. This gap is increasing, but the ratio between the pairs of numbers as you see them is the same. It is a common ratio. Now, as I say, there are complications. There always are, but these are the very, very basics. And that is how you distinguish between an arithmetic and a geometric sequence. And I hope that this has cleared up some of the misconceptions in this area, and that it has made some sense to you. If it has, please like, and if you found this useful, subscribe. There's plenty more on this channel. Thanks very much for watching. Bye.